So when you write code in Python, you will often have to iterate over some array. And that can be a problem in Python because that can be very slow. But JAX gives you a very efficient way to work with those arrays, and that is the so-called scan function. JAX also gives you their own versions of the for and while loop, but in general, the scan function will be the most efficient one because it works with static sized arrays, while these ones can be more dynamic. And if you have a look at the documentation of the scan function, it will say scan a function over leading array axes while carrying along state. And it's not immediately obvious what any of these means, but this documentation contains three parts, which is scan a function over leading array axes and then while carrying along state. And we know what the second part is, over leading array axes. For example, if you had an array like this, which has only one dimension, then the leading array axes would point in this direction and your input would be each of these elements. But if you had a matrix, for example, then the leading array axis would go in this direction and your input would be the entire row. And as an example, here we have this array XS, which contains 5 elements, 1, 2, 3, 4, 5, and the leading array axis would go in this direction, which means that the inputs for later will be 1, 2, 3, 4, and 5. And while carrying along state implies that we'll have some initial state, which we define as C0 equal to 0, and that will get passed as we iterate over the array. And for the final part, before we define this function, let's think of a goal that we want to achieve with the scan function. And let's define this goal as computing the cumulative sum of an array. In this example, the cumulative sum would be 1 plus 2, that's 3, 3 plus 3, that's 6, 6 plus 4 is 10, and then 10 plus 5 is 15. So the cumulative sum of this array is 15. And let's forget about the scan function for just a moment and think of a way how we would solve this problem in general. I have some pseudocode right here, and the way you would solve this is you would define some initial state, some counter, I equals 0, and then you would iterate over this array and simply add x to I and then finally return I. But JAX wants you to think in the functional programming way, and in functional programming you cannot change I because in functional programming variables are immutable. So the way you would solve this in functional programming is to define a function which gets the current state as input as well as the current input x, and then it would simply return I plus x. So if you replace this line right here with this function and just say that I is equal to f of I and x, which is simply the sum of I and x, then this function is equivalent to this line right here. And that's exactly what we do with the scan function. So we need to define the function that we want to scan, which we'll define as f of c and x, c being the current state, x being the current input of our array, and then we simply return c plus x. And we also return one more thing. So later when we write the code, we will return a tuple. The second part is optional, so we can also return none here. But for now, we will also return the current state as the second position of our tuple. And for now, you can ignore this, but later you will see what I mean by this. So to summarize, we have our input array XS containing 5 elements. We have our initial state C0, and we have our function which simply returns the sum of the current state and the current input, exactly as we defined here in our pseudocode. And now let's go over what the scan function does step by step. Since we have 5 elements in our array, we will have 5 iterations in our scan function. And for the first iteration, we get as input C0, that's our initial state, as well as the first input of our array being 1. So what you do here is you have 0 plus 1, and the second thing that you return is C, which is 0 in this example. So you return 1 and 0, 1 being the next state, C1, and 0 is what I define as Y0. Now for the next iteration, you get the output from your previous iteration, which was 1. So the current state is now 1. You get that here as input, and you return 1 plus 2 and 1, which means that you return 3 and 1. 3 being the next state, C2. Now this 3 becomes the input of the next iteration, and now you have 3 plus 3 and 3. So you return 6 and 3. 6 becomes the input of our next iteration, and now you return 6 plus 4 and 6, which means that you return 10 and 6. 10 being C4, the next state, which becomes the input of the next iteration, and now you have 10 plus 5 and 10. And the final state that you return is 15. And the way we arrived at this 15 is exactly as I showed in the beginning, where you had, well, the initial state is 0, so you had 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15, which is the exact computation we did here. So 0 plus 1, 1 plus 2, 3 plus 3, 6 plus 4, and 10 plus 5. So our scan function, if we give it as input our function f, the initial state c0, and our array xs, will return 15, and it will also return all of these intermediate values that we returned as the second position of our tuple, which is in our case 0, 1, 3, 6, and 10. So in other words, the second part that we returned here as in our tuple got stacked into an array and then returned as the second index of the return tuple of the scan function. So to summarize, the scan function returns the final state 15 as well as all the intermediate values that we return here as the second index of the tuple. But as I said before, this second part is optional, so you can also return none, and then in that situation you would get 15 and none as the return from the scan function. And that's basically all there is to it. So now let's go to the editor and see all of this in action. So before we get started with the scan function, I first want to show you the problem with traditional for loops when it comes to working with JAX. In our earlier example, we wanted to compute the cumulative sum, so let me just write out the function for that. So here we have our function, and if we run this code, we can see that the cumulative sum is 15. But now let's have a look at the JAX expression that gets generated from this function. If we run this code again, you can see that we have quite a few operations here that need to be performed. And this gets worse as our input array gets longer. So for example, if we had 60 elements, then as you can see, our JAX expression gets really, really long. And this is not an efficient way to iterate over arrays. And now let's try to optimize this using the scan function from JAX. From our overview earlier, we know that we need 3 parts, which is the function that we want to scan, the initial state, as well as the array. So over here we have our input array, and now let's define the initial state as being equal to 0. Next up we need our function. And if you remember from the example earlier, we basically want to transform this line right here into a function. And our function will get as input the current state c as well as the current input x. And it will return a tuple. And here what we want to return is, well, for one, it's the next state that we need to compute. And we also want to return the current state c. And now that we have defined our function, we have all the ingredients to call the scan function. And if we run our code again, we should see the final state as well as all the intermediate results exactly as we defined earlier. And sure enough, we can see here the final output 15 as well as all of our intermediate steps. Just to show you that the second return here is optional, I can say that it's none. And if we run the code again, you can see that we get 15 as our final state as well as none. And the beauty of all of this is, since scan is a primitive operation, if we have a look at the JAX expression, then you will see that it simply consists of a single operation right here, as opposed to all of these operations over there. And because of this, scan is a very efficient function. So whenever you have static sized arrays and you have the option to use the scan function, then you really should use the scan function. I really hope you enjoyed this video. Thanks for watching, and I will see you in the next one.